Good afternoon, everybody. Myself, Acharya Vishvendra. Today, I'm going to discuss a worksheet on the capillary tube itself, as you can see in the figure. So, let's begin with things. Well, here is a worksheet on capillary tube. So, capillary is a tube basically which is dipped in a liquid, and liquid rises in it. It may also descend, but we assume that liquid rises in it up to height h. So, we are being given the question that a capillary tube has radius small r is put in a container of liquid having density d. Angle of contact here is theta, and we need to find. The first question is height of liquid ascent in the tube. So after calculations by considering the equilibrium of this part of liquid and applying forces, we get height as 2t cos theta by dgr. I'll be making a separate video on the derivation of this, but in this worksheet I just discussed the basic concepts and the equations which are of use in the exam. For derivation, I'll be making another video. So after analyzing the height, we can say that this height is proportional to t. So the graph will be a straight line. Tan alpha is h by t, which is 2 cos theta by dgr over here. Next is if we draw graph between h and theta. So we have a graph of cos theta which is maximum at 0, and at 90 it will be negative, and at 90 it will be 0, and at 180 it will be negative. Now there is a question that what is the effect of theta on h. So we discuss two different cases. First is theta less than 90, another is theta greater than 90. So if theta is less than 90, then height will be positive as cos theta will be positive. So on increasing theta, we can see that height decreases. And if theta is greater than 90, so height will be negative. That means it will descend down. So if it will descend down, that on increasing theta, as you can see over here, more magnitude of height increases. So it's a bit different for those things. Next is if you draw graph between h and d, so these are inversely related. So it will be a rectangular hyperbola, whereas graph between h and 1 by d will be a straight line. Similarly, graph between h and r will be rectangular hyperbola, and between h and 1 by r will be a straight line. Then we have what is mass of liquid. So mass is density into volume. Volume will be pi r square h. So after calculations, we get mass is proportional to r. Next is a question on capillary tubes of radii r1, r2, heights liquid h1, h2. Then find. First question is h1 by h2. So height is inversely related to radius. So h1 by h2 will be r2 by r1. Then we need to find ratio of volume. So volume will be pi r1 square h1 pi r2 square h2. So after calculations, we get that r1 by r2 as r1 h1 is equal to r2 h2 for both the capillaries. That is depends on the liquid only. We can verify this. Next is ratio of masses. So mass ratio will be equal to the ratio of density. Mass ratio will be density into the ratio of the volume. So liquid is same, so density will be same. And just a moment. So here density is same, so it is equal to V1 by V2, which is equal to R1 by R2. Next is work done by gravity. So if we have the air column of height h, so its center of mass will be at h by 2. So if we take this as the reference, then work done by gravity is minus mgh by 2. Next is work done by surface tension. So after calculations, it comes out to be mgh by cos square theta or mgh sec square theta. There is heat produced. So heat produced is the difference between work done by surface tension and work done by gravity. So work done by gravity is negative, so I have omitted here. I have just taken the magnitude. So heat produced is mgh by cos square theta minus mgh by 2. So these are the simple worksheets to optimize your time and energy for best performance in exams. Thank you and have a nice day.